Hello and welcome back to my Blind 75 series. Today we're going to be talking about question number 3, also known as longest substring without repeating characters. This is a medium level question, and like many other medium level questions, this question looks to compound several different ideas into one. Today those ideas will be the hash table and the sliding window, which we will be implementing into our solution. The problem goes as such. Given a string S, find the length of the longest substring without repeating characters. So simple enough, all we're gonna be doing is we're gonna be taking a string, we're gonna be checking each character to see as long as we go through the string that we do not receive a duplicate character. So if we look at this first one right here, we're gonna see we get A, B, C, and then there's another A. So that means that we have a repeating character. So this string right here is going to be only a max length of 3. So after that, we're going to start from here. We're going to get to A, B, and C, and then we're going to get a repeating character again, which is B. So that's also going to be the same length of 3. So it's going to stay the same. And then right here, we have B and B, which are duplicated. So this does not count. Same thing here. If we look at this string down here, this is all just one repeating character. So in this case, we're just going to return 1 because the max length of non-repeating characters in the substring is only going to be equal to 1 because every string character is the same. So let's go ahead and break this down. All right, so we have this string right here. And what we're going to be doing here is we're going to take this string, we're going to be using a sliding window approach to work through this problem. So we're going to have our scene dictionary, which we're just going to call scene. And we're going to have our dictionary, which is going to go here. And all we're going to be doing is we're also going to have a max length, which is going to be how we're going to determine the max length of the string at the end, and this is what we're going to return at the very end of the function. And we're also going to have a start, and start is going to start right here. Now as we loop through the string, we're going to be adding each of these values across the string into our scene dictionary, and we're going to be expanding our window as we go along. And the start is going to be the start of our window, and we're also going to have an I value, which is going to be our current index. Also our character is going to be the beginning of our string. So the start is where we're going to start it off, and this is where we're going to move forward throughout it to increase our window. But that's only if we encounter the character inside of the current dictionary. So first things first, we're going to add A into the dictionary. So we're going to put A, and then we're going to move I forward by 1. So I is going to move up because A and B are not the same. And then we're going to add B because B is not currently in there. And then we're going to move I up again because we're going to check and see that C is also not equal. So C is going to be in there as well. And we're going to add that in. We're going to put C. And then at this point, we're going to move our I forward again. But what's going to happen is instead, we're going to see that our index value, or our current character value, is already in our scene dictionary. So because it's already in our scene dictionary, that means that this is the current end of our dictionary, and we're going to find the max length of this, and we're going to compare. So right now, our max length is 0, but now, after looking at this, our max length is going to equal 3. And we're going to compare that 3 and that 0, and we're going to get 3. So now that we've determined that, and we have our current max length, because we've reached a duplicate, we're going to move our startup to our next value. And we're going to have our index is also going to start there. And then we're going to do the same thing. So inside of scene, we're going to get A, and move over this value I. We're going to get B, move over our value I, C. It's the exact same as before. And then we move over I again, and once more we reach a duplicate. Now once again, this substring is going to equal 3. Now is 3 greater than our max length? No. So they're exactly equal to each other. So therefore, there's nothing we can do here. We already have 3 as our max length. And what we're going to do is we're going to move our start up again. So start is going to go to B, and we'll delete these out of our dictionary. And we're going to see that B is our first value. And next we move that I up, And B is already in scene. So this just ends it right here. And this is a value of 1. And then we can check one more time. Is 1 greater than 3? No, it's not. So in that case, our max length is going to be what we return. It's going to be 3 because we've gone all the way through. We've created our window. And at the end, we have realized that our longest substring is going to be a 3. And that is the simple way to do it. All right, so let's go ahead and take this over to LeetCode. And what we're going to do first is we're going to create our scene dictionary. And this is where we're going to be keeping our values that we've already seen, the characters that we've already seen, to know what is our current substring. After that, we're going to create our return value, which is going to be max length. We're just going to call it max len. And then that's going to equal start equal to 0. So start is going to begin at the index 0, which is going to be the beginning of our string. And that can equal max length at the beginning, which is also going to be 0 because we currently have no max length. For our loop, we're going to be using enumerate. So we're going to have I and C, which is going to stand for index and character in enumerate. And one quick note on enumerate, this is a useful loop to learn for these types of coding interviews. They're much more impressive to use than your regular range len or something of that sort. You can still use something like a while, you can use the range len, but this gives you the ability to use the index and the character in one value as opposed to having to use the index type value to be able to get your character. So it just adds a little bit less confusion once you understand how enumerate works. Let's go ahead and go to our next line. So for this first line, we are going to be checking if our character is in scene and start is less than or equal to scene C character. In this case, start is going to equal scene character plus 1. So if our C, our character value, is in our dictionary, just like we said before, if we got to this point, this A, this is going to be the condition that we're going to meet. And start is less than or equal to scene C, so the current character. And what this means is that we're not just at the start of our window. So we're making sure first that we didn't just start a new window, because if that was the case, then this would be premature and we wouldn't want to restart and move our start value forward. So in the case that we already reached the value, we get a duplicate value, we're going to be moving forward. We're going to move start to that value. So start now is going to be at the A because that's where we're going to be the start of our new window. Else, in the condition that we do not get to a duplicate, we're going to check to see if our max length has changed. So we're going to take the max of our current max length, and this is a really useful piece right here for two reasons. First, max is used a lot. Max and min are used regularly, especially for longest substring type problems or similar problems of that sort. So keep those in mind. There's a few others that are used. This uses the exact same kind of idea. A lot of dynamic programming problems too. And this piece right here as well, I minus start plus 1. This is going to be our window length. So we're going to take I, which is our index, minus start plus 1. And the reason that it's start plus 1 is because, as you remember, our index is always off by 1 in terms of length. So we always start our index at 0, which means that there's a number that's not accounted for. So we have to add 1 on in order for us to get the correct value. If we do not do that, then it's going to come off 1 short of our actual length, which is going to be incorrect. And technically you could do it the other way if all of them started that way, but you at that point could get a max length of 0, which would be not good. And for our last line, all we're going to be doing is saving the value into the index. And I described it a little bit differently. I just created new dictionaries each time. But in this case, it's just going to be taking that value and adding the index value inside of it. And it has to be subsequent for it to work. And at the end, all we're going to do is return that max length. And we're going to go ahead and run it first. Make sure that it runs okay. Okay. Let's go ahead and submit. And here we get a 96.91% faster and 60.80 less space. And so this is going to give us a time complexity of O of n and a space complexity of O of n as well. And the reason for that is because we do use a dictionary and we do use a loop, so that's going to end up creating the time and space that is O of n. And that's all. I hope you enjoyed this video. Please take the time now to subscribe to my channel if you enjoyed this video. I'm going to be continuing this Blind 75 series. Make sure to also like this video. And please, if you have anything to comment or say, or if you have another problem that you would really like me to explain, you leave a comment to let me know any questions that you may have or other problems you'd like me to go over. Until next time though, have a great rest of your day and happy coding.